Good morning, children. Let us learn a topic from class 6, chapter 2, whole numbers. Before learning about whole numbers, let us recall the previous topics and the concepts. What are the concepts we have learned previously? In the lower class, that is in the 5th class, you people learn about number systems. One is Indian number system and another one is international number system. Once let us recall the number system. First of all, what is Indian number system? What is Indian number system? This Indian number system is consisting ones, thousands, lakhs, crores. So by this way we can take the number name and the numbers. Let us take that. First of all, this is consisting one's house and another one is thousands house. Another one is lakhs house. Lakhs house. Another one is crores. So what the Indian system is consisting? It consisting this type of houses. One is one's house, another one is thousands, another one is lakhs, another one is crores. What that one's house consisting? One's house consisting again three sub houses. That is ones, tens, hundreds. Thousands consisting thousands, 10,000s. Lakhs consisting two houses, that is lakhs, 10 lakhs. Crores again consisting crores, 10 crores. So these are the sub houses in the Indian system. That is one's house consisting three places. One is one's place, next is tens place, next is hundreds place. Thousands consisting two things. That is two houses. That is thousands place and 10,000 place. Lakh also consisting two places only. One is lakhs and one is 10 lakhs. Crores also having two places. One is crores and one is 10 crores. So by this way we can make a number. We can give the word to the number. Suppose some digits are in the respective places. Suppose here there is a number 2, here 5, here 1, here 6, here 3, here 4, 0, 2, 7. So in each and every houses and each and every places there are some digits. In the one's house we have three places. In the thousands house and the lakhs house and the crores house there are two places. So by this respective houses we will give the name of the number. Now coming to the crores place. In the crores how much number is there? 25, that is 25. In the crores there are two digits. One is tens crores having digit 2, crores having digit 5. Like that, lakhs also having two digits. That is 10 lakhs digits. 10 lakhs place having digit 1, lakhs place consisting digit 6. So thousands place also having 10,000 place 10,000 place having 3 digits. Thousands place is having 4 as a digit. And in hundreds place you have 0 as a digit, in tens place you have 2 as a digit, and in ones place you have 7 as a digit. So how can we give the name of the number? So in the crores house you have 25, in the lakhs house you have 16. I am separating by drawing one more line for ones, thousands, lakhs and the crores. So by this way what you will get? The name as, in the crores you have 25, in the lakhs you have 60, in the thousand you have 34, in ones you have 0 to 7. So how can you read the number? How can you name the number? Means in this crores we have 25, therefore 25 crores 60 lakhs 34,027. So that is the name of this number. What is the name of this number? This number is nothing but 25 crores 60 lakhs 34,027. So by this way you can write the number. How do you write the number? This is nothing but 25 crores. So in between houses, suppose this is crores house, means 25 is in crores house, 16 is in a lakhs house, and 34 is in thousands house, and 27 is in ones house. So to represent the respected houses, we will be taking a sign comma for the respective houses. So here one's house consisting 3 digits, 3 place values. One is ones, tens, hundreds, and the thousands house consisting 2 place values. One is thousands and another one is 10,000. Lakhs house consisting 2 place values. One is lakhs and the one is 10 lakhs. And the crores house consisting, one is crores and another one is 10 crores. So by keeping comma we can identify the respected houses. So 25 is in which case? That is in the crores. Therefore 25 crores. First of all, I will write the total number 2516342027. So how do we represent? This is the number in Indian number system. Means by keeping comma, that commas are separated by respected houses. Here first house is one's house, another one is thousands house, another one is lakhs house, and another one is crores house. So here houses are separated by two digits. So that means ones, tens, hundreds, comma, thousands, 10,000s, comma, lakhs, 10 lakhs, comma, crores, 10 crores. So therefore this is 25 crores, 16,000, 34,000, 25 crores, 16 lakh, 34,000, 27. Now in this again let us take the international system. What is international system? Already you have learned international system, that is consisting ones, thousands, millions and billions. Let us draw the chart. Go. In international number system we have houses like ones house and thousands house, millions house and billions house. So one's house consisting 3 places. What are the 3 places that are ones, tens, hundreds. In thousands also having 3 places. In Indian system, in thousands have 2 places, but in international system, ones have 3 places, thousands have 3 place values, and millions also have 3 place values, and billions also have 3 place values. What are the place values? In thousands, thousands, 10,000s, 100,000s. Next millions, millions, 10 millions, 100 billions, billions, 10 billions, 100 billions. So in international system, each house consisting 3 places, 3 place values. One's place consisting ones, tens, hundreds, thousands house consisting thousands, 10,000s, 100,000, and millions consisting millions, 10 millions, and 100 million. Billions also having 3 place values. One is billion, another one is 10 billions, and another one is 100 billions. Suppose let us take some digit. This is 5, 3, 2, these are digits in the respected places. So comparatively, Indian system and international system consisting this type of houses, that is one's house, thousand's house, million's house and billion's house. Here each and every house consisting 3 place values. In Indian system, only one's house consisting 3 place values and the rest of thousands, lakhs, crores having 2 place values. But in international system, each and every house having 3 place values. So you can easily read the number billions. Billions consisting 3 digits. That is, what are the 3 digits? 532. Therefore, this is 532. So in millions, 546. In thousands, 123. In ones, 762. So it is very easy to read in international system. Therefore, the number is nothing but 532 billions, 546 millions, 123,762. So that is the name of the number. That is the name of the number. So here each and every house separated after each 3 digits. So that means what is the number here? 532, 546, 1, 2, 3, 7, 6, 2. So this is nothing but 532 billions, 546 millions, 123,762. So by this way we will go and we will learn and we will give the number name of the. Now let us learn the relation between international system and Indian system. International system and the Indian system. So in the international system, these are the houses. In Indian system, we have houses. So in one's house, it is directly one's only. And the tens place, it is tens place only. Hundreds again, hundreds only in Indian system. Now in thousands, you will get thousands. Here 10,000s. But in Indian system there are no 100,000s. You have get lakh, that is 1 lakh, and here you will get 10 lakhs. 10 lakhs. 10 lakhs. 10 lakhs after crore. Next 10 crores. Next you will get 100 crores. 100 crores. So by this way we can give directly the relation between systems, what the system, international system and the Indian system. So what the meaning of that relation? Suppose here billion. 1 billion is nothing but how many crores? 100 crores. 1 billion is nothing but 100 crores. So by this way we will give the relation. So by this chart we can easily give the relation between them. So what is that? 1 billion is equal to how much? 100 crores. 1 billion is equal to 100 crores. Suppose I want 1 million. 1 million means what in Indian system? 1 million means 10 lakhs. 10 lakhs. 1 million means 10 lakhs. And suppose 100,000. 100,000 means how much in Indian system? 1 lakh. 1 lakh. So by this way you can give anything. So 1 billion means 100 crores. 100 million means 10 crores. 10 million means 8 crore. 10 million and 1 crore both are same. So 1 million means 10 lakhs. 100,000 means 1 lakh. 10,000 means 10,000. Here on both are same. So by this way you would compare the both systems, international system as well as the Indian system. These are things you have learned in the 5th class. Now what we are learning here is we are learning whole number. What are whole numbers? Before going to learn whole numbers, we have numbers. Suppose there are some pencils. Suppose here like this figure is there. So how can we count? We can count these figures by 1, 2, 3. So like that we will count by using some numbers. Such numbers are considered as natural number. This also was introduced in our class. What are those natural numbers? What are natural numbers? Natural numbers are nothing but counting numbers. Natural numbers are nothing but counting numbers. So natural numbers are counting numbers. So natural numbers are counting numbers means what the numbers actually, the numbers are 1, 2, 3, 4, 5, like this we will count. So natural numbers means we are starting from a number 1 and so on. So this all numbers, if we keep it as a set, means this numbers nothing but 1, 2, 3, 4, 5, so on up to infinite, and these all natural numbers are represented by English letter n, that is capital letter n. So this one, on this representation, we will read it as n is equal to set of 1, 2, 3, 4, 5, so on. So we don't know the last number, how much we can predict. But what is the first number and what is the smallest one? 1 is the smallest as well as first number. 1 is the smallest and the first number. So we can easily say the answer for the question, what is the least natural number? So the least natural number here is n. The least natural number here is n. In this, it is there is a common thing. What is the common thing? I am getting 2. How I am getting 2? By adding 1 to this first number. I am getting 3 by adding 1 to the second number, that is for 2. If I add 1 to number 3, I will get 4. So that means we already learned this is the successor of this number. Means 5 is the successor of 4 and 4 is the successor of 3. So here the successor number is getting by adding a number 1. So 2 plus 1 I am getting its successor. 4 plus 1 I am getting its successor. So I am getting a successor number of the given number by adding 1 only. So in the natural number we are getting successor number by adding 1. Now what is the predecessor? You know it. The predecessor of 3 is 2. Predecessor of 5 is 4. Means what do you mean? We are subtracting 1. So by that way, if we continue, I am subtracting 1 from 4, I will get 3. If I subtract 1 from 3, I will get 2. If I subtract 1 from 2, I will get 1. If I subtract 1 from 1, what you will get? You will get 0. If I subtract 1 from 1, I will get 0. But this type of number is not in these numbers. What are these numbers? Natural numbers. So if I take 0 also by subtracting, so what I am taking 1, 2, 3, 4, 5, these are natural numbers. Means to get predecessor, I am subtracting a number 1. So that at once I am getting 0. So what next number? Successor of its successor of 0. Successor of 0 is 1. Its successor is 2. Its successor is 3. Its successor is 4. So like this. So here we are having 0 also as a digit. So whenever we are taking 0 also as a digit under natural numbers, this whole thing will be considered as whole numbers. That whole number sector is denoted with the capital letter W. So these are the natural numbers and these are the whole numbers means how can you represent these numbers on a number line? Already you have know that number line. What the number line? It is simply a horizontal line and horizontal line and some lines drawn which are separated equally. Then if we mark lines at equal intervals and we keep 0 as a first number and the next is a successor, by adding 1 we will get successor, that is 1, its successor is 2, its successor is 3, 4, 5, 6, 7, 8, 9, 10, so on. So this representation on a line is considered as number line. Number line. So this is the number line for whole numbers. This is nothing but whole numbers line. Why? The numbers are started from 0. So the numbers are started from 1 means natural number. The numbers are started from 0 means whole numbers. Whole numbers number line consisting 0, 1, 2, 3, 4, so on. Natural numbers number line consisting 1, 2, 3, 4, 5, 6, so on. So what is the use of this number line and how can we use this number line? This number line we use for doing some operations like addition, subtraction, multiplication, division also. So how it is easy to add or to subtract or to multiply numbers. Let us then these operations. What operations? Operations under whole numbers. What are whole numbers? Whole numbers are 0, 1, 2, 3, so on. That means the smallest whole number is 0 because the started number in whole numbers is 0 only. Now what are the operations and how we will operate through number line? Let us start addition. Take one example. What is the example? Find the sum of 2 and 5. That means add 2 plus 5. How do we add? How do we represent this addition on the number line? Here what is the question? 2 plus 5 means what is 2? Here 2, here is 1 and here 2, here is 2. That means this plus this is nothing but 2. So this is 2 units distance. So from this, how many units we should be added? 5 units. That means how do we represent? Already 2. 2 means here to here is 2 units. So from this, what is this? We will take 5. So 1, 2, 3, 4, 5. So I am adding 5 units. So how much sum we got? Up to 7. That means this 7 is the sum of this 2 and 5. That means 2 plus 5 you can write it as 7. So by this way you can represent the sum of the whole numbers. That is addition. Addition of 2 whole numbers is like this. Addition of 2 whole numbers is like this. That one will get reflected on the number. Now subtract. Take one example. Example. Suppose 5 minus 3. 5 minus 3. 5 minus 3 means here how much? Where is the 5? Here is the 5. That means 1, 2, 3, 4, 5. This is a 5. So from this, how many have to be subtracted? 3 units. So that is 1, 2. We should come from back. I am coming from the back side. That is 5 to 4, 4 to 3. So this is 1 unit. This is 1 unit. Now third unit, that is here. So what you will get? 2 is the solution or 2 is the difference of the 5 and 3. So by this way we will represent the subtraction on whole numbers line. On whole numbers line. Multiplication. Suppose the example is 2 times of 4. 2 times of 4. That means what? 2 units repeated by 4 times. 2 units repeated by 4 times. How you will represent that one? 2 units means from where to where? Here to here is 1 and here to here is another 1. Therefore 2 means this is 2. This is a 2. So how many times was repeated? 4 times is repeated. 2 is repeated 4 times. That means 2 times of 4. That means one time I have taken more. One more time is here to here. That is one more 2 and again one more 2 and again one more 2. So 2, 2, 2, 2, 2, 2, 2, 2. I have repeated 2 how many times? 4 times. So what product you got? 8 as a product. So this 2 times of 4 is nothing but 8. So by this way we would represent the multiplication on a number line. So this is the way to find addition on the number line, subtraction on the number line, multiplication on the number line. By this way we will represent the operations on the numbers line. Let us learn properties of whole numbers. Actually, what are the properties under, or what properties involved in the numbers? Generally, there are properties like closure property, commutative property, associative property, identity property. Some more also are there: inverse property, distributive property. But let us learn these 4 properties. So, closure property, commutative property, associative property, identity property. How the whole numbers are involving and satisfying these 4 properties. Actually, what is closure property? To describe this property, we must consider operations. What are the operations we have? We have operations like addition, subtraction, multiplication, and division. These are the 4 operations. We are technically, these are also called as binary operations. So under these operations, how the whole numbers are satisfying these properties? Again I am repeating. Under these operations, how the whole numbers are satisfying these properties. Before going to that, what is closure, what is commutative, what is associative, what is identity? Let us learn one by one by using either of the operations. For under addition, how can you explain closure? For this, I will take any whole number. What are whole numbers? Whole numbers are numbers which start from 0. The smallest whole number is 0. The biggest number is undefined because we don't know. I am taking any 2 whole numbers. For that, I will take 2 is one of the whole number and 5 is one of the whole number. If I add these 2 numbers, I will get 7 as a sum. What operation I have used? Addition operation I have used. 2 is a whole number, 5 is a whole number. Sum of these 2 whole numbers is whole number. 2 is a whole number, 5 is whole number. Sum of 2 whole numbers again whole number. If that condition satisfied, what is the condition? First number is a whole number, second number is also a whole number. Sum of these 2 whole numbers will get is whole number. Then that whole number set satisfies closure property under addition. So simply 2 plus 5 is equal to 7. It is a whole number. Suppose if I take operation minus 2 minus 5, I can't subtract because this is the small one, this is the bigger one. I can't subtract the bigger number from the smaller number. So this is not a closure. It means whole number is not satisfying whole numbers, this is whole number, this is whole number. These are not satisfying closure property. Under what operation? Subtraction operation. Clear? So that is the meaning of a closure property. Closure property means 2 plus 5. 2 is a whole number, 5 is a whole number. The sum also whole number means then that whole number satisfying closure property under addition. If we take multiplication, 2 whole number, 5 is also whole number. Multiplication is into. So the product 10 is also a whole number. Therefore, multiplication means whole numbers are closer under what operation? Multiplication operation. That means whole numbers are satisfying the closure property on what operations? On the addition as well as the multiplication. Next, commutative property. What is commutative property? I will take two whole numbers, 2 and 5. I will add. So what the sum of 2 and 5? 7. I will interchange. What is that? 5 and 2. I will add 2 for 5. Here what I did? I have added 5 to 2. Here what I am doing? I am adding 2 to 5. Means here I have interchanged the numbers. So by adding 2 and 5, I will get the sum 7. By interchanging the digits or numbers, again I will get the same number. Therefore, by this way, it is satisfying. That means by interchanging the digits, also we will get same result. Then that property comes under commutative property. That means whole numbers are commutative. Whole numbers are commutative under addition operation. Both are equal. On interchanging of numbers, are we getting same result or not? Yes, we are getting same result. If not, it is not commutative. We are getting same result, therefore it is commutative. Multiplication. Same thing I will take. 2 into 5. I will interchange. So what is the interchanging of 2 into 5? 5 into 2. So 2 into 5 I will get product 10. 5 into 2 I will get product 10. So both are same. Both are same. So this one is comes under commutative property. That means whole numbers are commutative under addition. Whole numbers are commutative under multiplication. In the question, in the textbook or in the exam, you will get 2 plus 5 is equal to dash plus 2. So it is clearly satisfying commutative property. Therefore, you will get the how the commutative property is going on. The commutative property is going on by the interchanging of the digits. So here 2 plus 5. So what is the interchanging? What you will get? 5 plus 3. So by this way. So 2 into dash is equal to 5 into 2. So 2 into dash is equal to 5 into 2 means here also commutative properties condition means what is the interchanging of 5 into 2 into 5. So by this way we will fill the blanks by using the properties, by using this property, commutative property. Next one is associative. What is associative? Associative property, we will take 3 numbers. I am taking 3 whole numbers like 3, 2, 5 and 4. I am taking 3 numbers. 2 is a whole number, 5 is a whole number, 4 also a whole number. Now again I will take same numbers like this 2, 5, 4. First I will make 5 and 4 as a group. 5 and 4 as a group. I am adding. With this sum I will add another one. This is 2. Is clear? So I am taking 5 and 4 as a one group. Here I will take 2 and 5 as one group. I am now taking operation addition. So I am adding 2 for what sum? For 5 and 4. What is 5 and 4? 9. For this 9 I am adding 2. So I will get 11. Now here 5 and 4 maintaining as one group. Here what I did? I have changed 2 and 5 as a one group. So what you will get is 7. 2 plus 5 is 7 plus 4. And 7 plus 4 is 11. So what I did here, I have taken 3 different numbers, 3 different whole numbers, and using these 3 different whole numbers, I made 2 different groups. 5 and 4, in the first case I have taken 5 and 4 as one group. In the second case I have taken 2 and 5 as another group. 2 and 5 as another group. So by adding these numbers, at last the result is 11 in this case. Here also the result is 11. So both are same. So what happened? Here by interchanging or by changing the groups, the result never changes. If that condition satisfied or such situation satisfies, that things are considered as associative property. That means here 3 different numbers. I made different groups. By taking 3 different numbers, I made different groups. At that time also, result is not changing. That condition is considered as a associative condition or associative property. This is whole numbers are associative under operation addition. Whole numbers are associative under operation addition. What is the multiplication? Same things I am taking 2, 5, 4 and 2, 5, 4. I am taking multiplication. Here first I make 5 and 4 one group. Here I will make 2 and 5 one group. So what is this product? 20 as a product. 2 into 20, so 40. Here what is this product? 2 into 5, 10 into 4. So 10 into 4 is 40. So have result changed? No. Result is not changing. So that means by interchanging or by changing the groups, if result is not changed, result is same, then that condition is considered as an associative property. Associative property. So that means under multiplication, these whole numbers are satisfying associative property under multiplication. Whole numbers are satisfying associative property under addition. So by this way, we can understand what the product property, what the commutative property, what the associative property. Another thing is identity property. What is meant by identity property? Now, identity property. What is identity? I will take one of the whole number 2. I have taken a whole number 2. What number, if I have added to 2, the result becomes 2? Means what number, if I have added to the number 2, the result is 2? Means 0. What is 0? Smallest whole number. 0 is smallest whole number. So if I have added a number 0 to the number 2, result is 2. Not only that, suppose I have taken one more whole number 5. So that what number if I have added to 5, so that I will get 5 means again 0. Means if we have add 0 to any number, we will get same number as a result. Again I am telling, if we add 0 to any whole number, we will get the same number as a result or same number as a sum. Therefore, this 0 is called as identity. Means what operation we are taking? Addition operation. So this 0 is additive identity. What is 0? 0 is additive identity. What is additive identity under whole numbers? 0. Now coming to the multiplication. Same thing. I will take one whole number like 2. I want the result 2 to multiply. By what number if I multiply to this number, so the result is same, means 1. If I multiply by 1 to the given number, I will get the same number as a result. Not only that, suppose if I take 5, I will get 5 if I multiply to this 5 by 1, then only we will get 5. So if I multiply by 1 to the given number, I will get same number as a product. If I multiply by 1 to the given number, I will get same number as a product. So therefore, here 1 is multiplicative identity. Multiplicative identity. Is additive identity satisfies in the natural numbers? No, because 0 is not a natural number. In the natural set, the numbers are starts from 1 onwards. Therefore, there is no 0 in natural numbers. So, this identity property not satisfied by natural numbers. Identity property and addition is satisfied by only whole numbers. Multiplication is possible in natural number because 1 is there. But 0 is not in a natural number. Therefore, 0 is additive identity is satisfied in the whole numbers only, not in the natural numbers. So these are the general properties which are involved in the whole number set. Whole number set. By using these 4 things, we can complete the exercises, whole exercises in the topic. These are the main concepts involved in this lesson 2. In the lesson 2, that is the whole numbers. The smallest whole number is 0. That means the numbers which are starts from 0 are nothing but whole numbers. And we learn in this session what are the whole numbers, with what letter the whole numbers are representing, and how do we represent the whole numbers on a number line, what is the use of the number line, and what the operations can be solved using number line. Means addition operation, how can we solve in the number line? Subtraction, how do we solve in the number line? Multiplication, how do we solve in the number line? After that, we have taken the properties of the whole numbers. Properties of the whole number. The main properties involved in this whole numbers are closure property, commutative property, associative property, and identity property. 0 is called as additive identity. 1 is called as multiplicative identity. So what is the additive identity? Is 0. What is 0? Smallest whole number, or simply the first number in the whole numbers. So by this way, we can go through the whole numbers. It is very easy topic, and you can go through the textbook, and you can answer some questions from different exercises. Thank you.